So the last chapter of Math 109 really doesn't have anything to do with trig, but it is very helpful, especially when you take calculus. So we're going to start with some terminology here and develop a few formulas, but again, it has nothing to do with trig. So we're going to be looking at a sequence. So in math, a sequence is just a list of numbers. Now, it's not just any list of numbers. They have to have a specific order. So in other words, there's a pattern to these numbers, and that's why you started with the discovery, finding those patterns in those 5 representations. So a term is just a single value in that pattern, and we denote it with the small letter a, and then the subscript tells me what position. So my first position would be A1, my second position would be A2, or my third term would be A3. We just put commas, and those 3 dots means that this pattern would go forever. So the subscript is what we call that little number down there. Represents the position the value is in the sequence. So let's look at a couple different sequences. We really have 2 of them. Arithmetic means that you are going to add or subtract a value to get to the next term. And that next term is the next term in the sequence. We call that adding or subtracting value the common difference. And so we're going to call it D. And so how do I get D? I'm going to take and subtract 2 consecutive values. So we're going to subtract and see the difference between 2 and consecutive means that the values are right next, or the terms are right next to each other. So I have a sequence here that is going to be arithmetic. So in order to find D, I'm going to subtract the 2 consecutive terms, and I'm going to go -1 minus -12, which gives me 11. So that means my common difference is 11. I could have chosen 10 minus -1. I would have also gotten 11. So to generalize this, you take a term and you subtract the 1 before it. So if n is 5, n minus 1 is 4. So that means to get to the next term, I'm adding 11, and I get 21. So I'm just looking for this pattern. When I add 11, I get 32, and when I add 11, I get 43. So I would call 43 the 1, 2, 3, 4, 5, 6th term. That would be a sub 6. We found D to be 11, and it was positive because my terms were going up in value. So we're going to look and want to find any term in my sequence. Whatever term I want to do. I don't want to list them out, because if I wanted the 85th term, that would be a lot of numbers I would have to put in a row. So if we take a look at this, if I start with my first term, to get to here, I needed to add 111. And to get from -12 to here, I had to add another 11. So I added 2 11s to get to the third term. So on my first term, I would have had to add 3 11s to get to my 4th term. So if you notice a pattern here, we're always going to say the term I'm looking for is taking your start value, and you're going to add a bunch of D's. And how many differences am I going to add? N minus 1 differences. So you don't need to memorize this formula. Okay, it will always be given to you. But what this is saying is if I'm looking for my 7th term, it says start with your first term and add to that 6 of your differences, and that will get you there. Why 6? Well, if I'm looking, my first term didn't need a difference. That's where I started. So 6 of them added onto my first term gives me my 7th. So if I'm looking for the 40th term, there's no way I would want to write them all out. So the first thing I need to notice is I identify a sub 1 is 11. And between these, I can go 4 minus 11 and see that I'm going down in value by 7. I could have -3 minus 4. So regardless of which 2 consecutive terms, you can find your D. So D is down by 7 every single time. So if I'm looking for my 40th term, I take my first term. I'm going to add a bunch of D's. I'm actually going to add 39 differences because the first term didn't need a difference. That term was given to me. And so when I do that, I need 39 of my differences of -7. You can see it's decreasing in value. So I'm just identifying that term. So it's going to be 11 plus, I'm going to add a 273, which gives me a negative 262. So again, I could have listed out 40 terms. This is just a shortcut. Okay, so not only do we have arithmetic, we have geometric. So if you think about arithmetic being add and subtract, geometric is using multiplication or division to get to the next term. So when we look at this, we're going to not name it D, we're going to name it R. So how do I find R? Well, I'm going to take my terms and I'm going to divide them. I'm dividing consecutive terms. Notice I start with term 4 and divide it by term 3. Term 8 would be divided by term 7. So in general, the term I have would be divided by the one before it. So we're dividing consecutive terms. And so I'm going to find my R. And in order to do that, I take my terms. I could have taken 15 divided by 3. I could have taken 75 divided by 15. Regardless, I find R to be 5. And you can check that. 3 times 5 is 15. 5 times 15 is 75. So given this information, could I give a sequence that is geometric? So the key word here is geometric, means the multiplication of the order of the terms. Okay, multiplication was used to get it. And if I'm looking at arithmetic, this common difference was used. And we call this R because R is a ratio. Ratio means divide. So my first term is 4. To get to my next term, if I know R is 3, that would be 12, and this would be 36. So I'm multiplying by R's. So I used 1 R to get here. I used 2 R's to get there. So that would be R squared. So it's the same idea as differences, okay, but it's multiplicative. So if I'm looking for a formula, the term I'm looking for is going to be starting with my first term, multiplying by a bunch of R's. And in fact, I need n minus 1 R's for the same reason I needed 1 less D. My first term doesn't need it. I need 1 less R. So if I was looking for the fourth term, I would take my first term, which is 7. I would multiply it by R. And let's see, if I'm looking for my fourth term, how do I know it's the fourth term? I'm looking at that subscript. I need 3 R's. So that's why I'm going to put it to the power of 3. Remember, it's repeated multiplication. R cubed here would be 2 times 2 times 2. If my R was 2, which it was given to me. So this would be a power. And so it would be 8. So I could look at this and get 7 times 8, which is 56. Let's just check it. Because this is not asking for very many. It grows very quickly. If I multiply by 2, I'm going to get 14. If I multiply by 2, I'm going to get 28. Multiply by 2, double it, I get 56. And that is, in fact, my fourth term. So it was probably easier for me to just list these out. But if I was looking for the A of 20th, it's going to be a large term. So it'd be 7 times R to the 19th. And I'm pretty sure I would need a calculator to do 2 to the 19th. So if you think about it, this is multiplicative. And if you remember from Math 108, this graph, which is exponential, is multiplicative. And so you did a pattern in the discovery that was multiplicative. This is additive. And so if I'm adding every time, the graph of this would be a linear graph. Here my graph is growing. Here my graph is decreasing. Here my geometric is increasing. And here my geometric is decreasing. So hopefully those exponential linear graphs kind of are a reminder of what you did in Math 108.